Okay, so this is more 5.3, and so uh, let's get to it, and we'll do it. And so more discerning. Is it a shell? Is it a disc? Is it a washer? It really does get really cookbook, but it takes a lot of examples before it starts getting really cookbook. I hope that it's getting starting to get cookbook a little bit. I hope you can just do all of these examples already. I think on a normal semester where I didn't do a video, that I think I would have called it the first video would have been enough examples. So I hope that makes you not close this video, but so try them on your own. Use it as a little bit of homework, and see how you do on them. And if you're like, I can integrate those, just speed the video up right through that integration. Okay, so that just so that you have enough practice on it. I'm so tired that I can't think that I need to go to my paper review. Okay, so this is where we left off on 5.3. So I'm affectionately calling this now more 5.3. Lol is what I'll say, because that'll make me happier. And so they're asking us, it's saying which way, because all the others basically told us what we were supposed to do. And so they were all the disc, we had the disc section, the washer section, and the shell section. And so now it's not telling us what to do, it's making us decide what to do. And so but we've got that same situation. They all have the same situation going. That they've given you some curve, in this case y equals sine of 2x squared, and y equals 0. And so they have drawn for me y equals sine of 2x squared, which I didn't know that's what it looked like, but they've nicely drawn it for me. That was kind. And y equals 0 is right here, so I'll draw that on there. So this, and I like to dot the region that's being trapped. So there's my region that's being trapped. Okay. And they said that they said that this is going to be, the x's are between 0 and the square root of pi over 2. And so where that hits right here is at the square root of pi over 2. Let me make sure. And so right here, I want to make sure that when I put in pi over 2, the square root of pi over 2, and I times it by 2, and then I take the sine of it, I get 0. I'm suspecting highly that that's what they're giving me right there, is that point there, but I just want to make sure. I don't want it to be over here, you know what I mean, and me not draw the line and have it there. So that's what I'm going to do. I'm going to check. I think that that's probably where it's at. So right here, my calculator's in radians. I have sine, and I have 2, and then I have times, and then the square root of pi times 10. Why did I do that? Pi over 2. And then that whole thing squared, and then 0. Okay, so I suspected that that was the case, but I just made sure. And let's see, I think I have everything on there, but I didn't note that it's going around the y-axis. So that means if I'm going to use a disc or washer, that's always the one I start with, and I usually call it DW, D/W, and I affectionately call it the dishwasher method. And so if I'm going around the y-axis, then this will be dy. And this means your equations need to be solved for x. And then the shell method, and I have that listed over here nicely, will be the other, and the equations need to be solved for the other one. So this would be dx, and my equations would need to be solved for y. And I noticed, okay, my equations are solved for y. There it is, solved for y, and I can't change it. So this one would be the shell method again, which is good. I love the shell method. So when you're doing the shell method, you need to know the volume. I better give myself some room. Because I'm going to have to, I want to show you how to integrate this one. So my volume is 2 pi, and my integral, you're like, ooh, scary, right? That you say that I need room. And so remember, this was dx. So there is I've memorized that's the volume of the shell, 2 pi RH. And you can put the 2 pi out in front of the integral symbol. H is top curve minus bottom curve. And when you draw it, you can draw an H wherever you want, but you need to draw it in your solid region, parallel to the axis of rotation. So, so H right here is your top curve minus your bottom curve. So H is equal to, well, my top curve is that crazy sine of 2x squared, and my bottom curve is 0, which is nice. And then R, if you're just going around the y-axis, R is easy. And remember, it's supposed to be in terms of x, and that was supposed to be parallel, supposed to be perpendicular. Sorry, I'm tired. And so this is what R is, and this distance from the y-axis out to any point is always called x, so R is just x. And so this volume becomes 2 pi, and then x times sine of 2x squared dx. Okay. So I haven't quite got it set up yet, but I've almost have it set up. So if that's all I was asked to do was set it up, then I'm done, almost done. But I need my bounds, and my bounds are where H could go. And so H could go all the way here from 0, where it hits, all the way over here to the square root of pi over 2. They actually gave me the bounds right here. So this is 0 to the square root of pi over 2. And I had a hard time fitting that up there on there. And so in order to integrate this, I can't multiply it together, and that's what you normally do with a shell. And so I'm going to have to do a u substitution. And it's good that we practice our u substitution, because it is very necessary that you have your u substitution down when you go to Calc 2. And so I have to make sure that you have it down by practicing it. We have to practice it a lot, so much that whenever you see one that's a u substitution, you say, oh, thank goodness, it's just a u substitution. So this is my plan for the u substitution, is I got to let u be the inside function, which is 2x squared. And then du will be 4x dx. And then on the bounds, I'm out here in the middle, and I said I had to save space, and I'm in the middle. And so I'm like, oh, shoot, this was really dumb to be over here in the middle. But I think I'm going to fit this right here, and then I'll have a little bit more room. I don't know. Donna, what are you thinking? And so low bound is x equals 0. And so that would mean that u equals 2 times 0 squared, which is 0. So the low bound is x is 0 and u is 0. It didn't change. But the up bound, up bound, x was the square root of pi over 2. And so u equals 2 times the square root of pi over 2 squared. And that's kind of lovely, because when you square that, you get pi over 2, and you multiply it times 2, and you get pi. So the bounds are 0 to pi. Okay, so this is going to be equal to 2 pi. That's just out there, trying not to forget that. And then my new bounds are 0 to pi. And then I have x sine of u. And then my dx, I forgot, I like to solve that. I like to write this as du over 4x equals dx. So I'm going to put that right here, times, and instead of dx, right here I have dx, I'm going to put du over 4x. And if that x doesn't cancel with this x, which it does, but if I didn't have an x to cancel there, I'd be like crying, because that would mean u substitution didn't work. And so this is going to cancel that x with that, and I can put the 4 out here with the 2 that I already have out there, pi, and remember it's in the denominator. And so this is going to be, and don't worry, I am going to reduce this, but this is going to be 2 over 4, and then 0 to pi of sine of u. This was my plan, so I'm going to make my plan in a box. Okay, du. And no, I would not turn in an answer with 2 pi over 4. You need to reduce, right? And so, but the reason I didn't reduce is I wanted to show you where the 4 went, and so for me not to do 2 steps at one time in my head. And so now I'm going to take the integral there, but I think I'll reduce as I write it down here. This is my volume, right? And so as I reduce, this is pi over 2. And then I am going to take the integral now, the antiderivative. So I'm not going to write the antiderivative symbol anymore. I'm not going to write the summation, the big S anymore, the integral symbol. And the antiderivative of sine of u is negative cosine of u from 0 to pi. And then don't forget that that cosine's tricky, because the cosine of 0 is 1. So you can't just say minus 0, which I love to do. And so v equals pi over 2. And then I'm going to have my upper bound, which is negative cosine of pi, minus my lower bound, which is negative cosine of 0, barely fitting there. And I'm all cramped up trying to get this even so that you can even see it. And you're like, oh my gosh, are we going to fit that on there? And the cosine right here is negative 1. And then negative 1 times negative 1, negative times a negative is a positive. So this is going to be v equals, now you could just put that in your calculator if you're like tired. And I am, but I am going to still do it in my head. So this is 1, and then this is double negative makes a positive, and the cosine. So this is 1 plus 1, which is 2. So v equals pi over 2 times 2. So v equals pi. So if we spun this around, right? And so this kind of thing would kind of look actually kind of like this thing that Tyler made. When you spin it around, kind of has this hump, and then it would have the blank center. And so it kind of looks like this thing when you spin it around. Anyway, okay, so we did a lovely job on that one, and we got pi as our answer. And these next ones, if they're easy to integrate, I'm not going to integrate them because I'm tired and you're tired. I don't know if I'll be able to do it though. But I do want to show you all that are u substitution, because we're practicing our u substitution still and making sure that we have it down, or any that are trig substitution I for sure want to do. So it says, find the volume of the solid obtained by rotating a region bounded by these curves about the specified line. So same story. I have y equals the square root of x minus 1. I have y equals 0 and x equals 5, and you're going about the x-axis. I know, sweetheart. Are you tired too? I know. I'm sorry. My cat's meowing at me. I think she's saying, can you be done making that video? And the answer is yes, I want to be done making this video. I know, honey. I'm sorry. And so we're going to get, when I pick a few points, I'm purposely making nice numbers underneath. So when I picked 1, I got 0. That's the vertex. I want to get the square root of 1, so I'm picking x is 2. So I get the square root of 1, because 2 minus 1 is 1. Oh, I'm sorry. I'm going to pick 5. So I get the square root of 4, which is 2. And I think that's probably enough points. And I'm going to make my, it says make my basic sketch here, but I don't like people telling me what to do. And so I'm going to make it sort of there. And so over 1 up 0, over 2 up 1, over 5. So if this is 2 and this is 1, then this is about 5, up 2. You can't afford to be too particular. And I know that they've had us draw the same things over and over again. And so I'm hoping that we're getting good at them. And then y equals 0 is the x-axis. And then x equals 5. And so this is what's being trapped. And they're going about the x-axis. So they're going right here about the x-axis, they say. So I have my story, and my story is that if I'm going around the x-axis, then the dishwasher is dx, which means my equations have to be solved for y, which they are. If I'm going to do the shell method, then it would be dy, which means my equations need to be solved for x. This is equations solved for y, right? And my equation is solved for y. And I don't really like the washer method because I have to do two of them, and I'm like, I have to do two of them. And so, I mean, I would be tempted because I could square both sides and I could solve this equation for x, and I love the shell method, right? So I would be tempted to use the shell method, except for that I notice it's a disk, right? Because if I was to draw a typical R for my disk, it goes right into the solid. So it's not even a washer. And because it's going around the x-axis, it's just my curve. And when I'm doing the disk, so I'm like, oh, this is just perfect. So I on this one, I think I would be tempted to go ahead, even though the disk method isn't my favorite method. I could do the shell. I could do the shell method. I could make it work, but I think the disk method would be easier. So the area would be equal to pi times the integral of r squared dx. In this case, my r is just my curve, which is the square root of x minus 1. And I know that you're saying, wait a minute, if you're going to have to integrate a square root, you don't want to integrate a square root, but wait a minute, you're going to square r. And so I'm not going to really have a square root. So it's not even going to be a hard integral. And so this is going to be the square root of x minus 1 quantity squared dx. And my bounds are going to go from, remember, in terms of x, from 1 to 5. And so really my area is pi 1 to 5 of x minus 1 dx. And nothing could be easier than that, right? And so, and the shell method isn't harder, and you would get the same answer. So if you want a challenge, then go ahead and show me, do it both ways, right? If you want to try another one. And so this would be, the area would be pi times, and then this would be 25 over 2, when I put in 5, minus 5. That's my upper bound, minus my lower bound, which would be half minus 1. And so I said that I wasn't going to integrate it, but I can't help myself. And so I'm like, there'll be one person out there that is saying, I wish you would have integrated that one because I wasn't sure how to do it. And then I could say, well, there, I gave you a whirl on it. And so there might be also one person out there that says that I wish you wouldn't integrated it to make it shorter. And to that person, I say, put it on double speed through this part. And so I have 15 divided by 2 plus half. And so that's 8. So this is 8 pi. So we did a lovely job on this one. So we're figuring out which way to go. And I have my way of going and how to figure out which way it is. And I want you to also go and check out Rob Bob and Professor Rob Bob and see what you think. If you like how he does it. I have my way. My way is really systematic, really step by step is what it is. And sometimes that's really boring because it gets like it's like a machine almost. Okay, find the volume of a solid obtained by rotating the region. So the same story. Y equals x to the third, y equals 0, x equals 1, about the line x equals 2. And then they want me to make a basic sketch. Of course, you have to make a sketch. And they want me to say whether I'm going to use the disc or the washer or the shell. So I'm going to make my sketch here. I can graph y equals x to the third. It looks like this. And y equals 0 is going here. and x equals 1 is going here. And so I've just kind of drawn this in here, and this is the region that's being rotated, and it's being rotated, remember this was x equals 1, about the line x equals 2, which is over here. And this is what it's rotating around. And so I would tell myself that that's parallel to the y-axis. So I would write it out right here so that I don't mess it up. Parallel to y-axis, because that's important in my memory verse of how to know which one to do. So that when I do the dishwasher, and I always start with the dishwasher because whatever axis you're going around or parallel to is what it's going to be. So this is y, so it'll be dy. Other people have it memorized in starting with the shell and doing the opposite. And okay, that works too. But however you do, you just I have this routine, and the routine is like a machine. It's the same every single time. And then that would mean that the shell would have to be dx. That would mean these equations need to be solved for x. And this would mean these equations over here need to be solved for y. And I'm like, okay, my equations are solved for y, and I would rather use the shell method. So let me make sure the shell method would be good here. And I notice that I'm right here for my h, because I'm thinking the shell method. And remember that your h is parallel to the axis of rotation. So there's my axis of rotation. It's parallel. And here's my h. And the only way that you get good at these is practice them. And then h is equal to the top curve minus the bottom curve. And I'm going to just write top minus bottom because I've written curve so many times today that I cannot take it. And the top curve is x to the third. And the bottom curve is the x-axis, which is 0. So h equals x to the third. And then if you're going around the x-axis or the y-axis, I guess in this case it would be the y-axis, then the r is easy. If you're going around an axis other than that, then r is tricky. So r is a little bit tricky because I'm going around an axis other than the x-axis or the y-axis. So, but I'm going to still draw my r in. And where r goes is from h, and I like to draw it from the top of h, but it doesn't matter because it's a distance. But that for me, it's really important that it's drawn at the top. And then I label this r. And then I immediately say to myself, well, the distance from the y-axis to a point, so here's this distance from the y-axis to that point right there, is called x. And so what I have going on here is I have x plus r equals 2. So that tells me that r equals 2 minus x is what that tells me. And so I'll put that right here, 2 minus x. So it's a little bit tricky, but not entirely tricky. And then I'm going to put these together so that my volume equals, and it was a shell. I was doing a shell. So it's 2 pi RH, right? Dx, we said. So this is 2 pi. RR is 2 minus x. Our h is x to the third dx. And if you can multiply it together when you're doing a shell, the r and the h, that's what you need to do. If you can't multiply them together, then you're going to have to do a u sub. That's what's going to happen with them. But I can multiply this together, so that's good. I haven't got bounds on this, so it's where h would go. And h is going right here from 0 all the way to 1. So 0 to 1. So if they ask me just to set it up, and here they kind of are saying to solve it. They didn't tell me, just it said find the volume. And so I am going to go ahead and solve it. And so the volume will be 2 pi. 0 to 1 are lovely bounds. I love that. And this is 2x to the third minus x to the fourth dx. And I'm going to try not to lose my 2 pi, but you know I'm going to have to do that at least one time. And minus x to the fifth over 5 from 0 to 1. And so I don't have cosine, so I can be happy about the 0, right? And so this is, when you put in 1, this is 2 over 4 minus 1 over 5. That's your up bound, minus 0. And I know that 2 over 4 reduces, and I'm going to put that in my calculator. And so that's the reason I didn't care about reducing it yet, because it's not my final answer. So 2/4 minus 1/5 is equal to 3/10. Because I do use my calculator to do a lot of these, I don't have to reduce them in my head. Times 2 is, so the volume here is 3 pi over 5. And yes, I know I have a lot of examples. And the reason I have so many examples is because it took me at least this many examples to get it down my first time through of learning them. And so I just feel like just keep practicing them. And we'll practice them in class too. These are set up only, and I am not going to be tempted. I'm not going to be tempted to do anything other than set them up. Okay, so they say that they have y equals 4x minus x squared. I feel like we've had that today. And y equals, so they've drawn it, and I feel like we drew it as well. And y equals, so if you tell me it was different, then I'll believe you. Y equals 3, and so y equals 3 is that line right there. And we want it whirling around the line x equals -1. And so this is the area that we have going whirling around. So because that is parallel, and I would write it, because that's how I am, parallel to y-axis, that means the disk washer would be dy, and that would mean the shell would be dx. And so this would mean my equations need to be solved for x. This would mean my equations need to be solved for y. And I look over and my equations are solved for y. And so I'm like, okay, am I going to do a shell again? But fortunately, I'm not going to solve it. I'm just setting it up. The reason that I'm having us practice more shells is because it is a little bit tricky on that r. And so it's not tricky on h. Because h is, remember, h goes parallel to the axis of rotation, so I'm drawing h on there. There's h. And h is top curve minus bottom curve. And so my top curve is that parabola, which is 4x minus x squared, minus my bottom curve, which is 3, y equals 3. So h is equal to 4x minus x squared minus 3. And then I got to find r. And r is the distance from h to the axis of rotation. And to me, it's important that I draw it to the top. And that's supposed to be, perfectly looking parallel, perpendicular, rather, not parallel. But somehow it got just a little off, and I don't know why it's bothering me, but I had to fix it. So that's what r is. Now, I want you to remember that the distance from the y-axis, I'm going to write that here, distance from y-axis to a point is called x. Right? That's what it's called. It's called x. So right here is the y-axis, and this distance right there to h, that point at h, is called x, is what that's called. And then I have this distance over here, and that's over here to -1, so it is 1. And so what I know right now, I told you r can be tricky, is that r is the whole distance, the whole thing. Part of it is 1, the other part of it is x, so r equals 1 plus x. So I know others that we've done have been, have been x minus something, or the number minus something. Well, it can be whatever. It's in terms of x, and it can be just a little bit tricky if you're not going around the x or the y axis, and you just kind of have to be careful. So they asked me to set this up only, and that's all I'm going to do. I promise I'm not going to solve it. And so this is 2 pi, and then r, which is 1 plus x, and then h, which is 4x minus x squared minus 3 dx. And then my h's go from here, right here, h goes from here, which is 1, and all the way to here, which is that 3? 1 to 3. And so there is the setup of it. If I wanted to integrate that, I'm not going to integrate that, but I'd have to FOIL these things together. Okay, it's not FOIL because it would be 6 multiplies instead of 4. But, 1 times this, times this, times this, and then x times this, times this, times this. I'll get 6 things, of which none of them are like terms. And then I'll use the power rule to integrate it. And then from 3 to 1. And so that would be that story there. And we did a lovely job on it. It was beautiful. Example 4. Okay, same story because it's just having you practice. And so it's got the same curve and it's got the same region that's being rotated, but this time around the line y equals -1. And so I say to myself, this is parallel to the x-axis. So that if I was going to use the dishwasher, it would be dx. If I was going to use the shell, it would be the other thing. So this is parallel to the x-axis. This is x. And then this would be dy. This would mean my equations need to be solved for y. This means my equations need to be solved for x, right? So I look at over at my equations, and this equation right here is not an equation that I can change it. So it's solved for y, and I'm not, so even though I love the shell method, I'm not going to be able to solve for x. So that means I'm going to have to use a disc or a washer. And so what you do to figure out which one you're going to use is that right when I go to the axis of rotation and I go to draw my R, here is my solid region. I'm going to solid that in so that you can see it, and I'm immediately in air. That air is the hole in the center of that air that I'm in. I haven't drawn it in 3 dimensions, but that hole is the hole in for my washer. And so I'm like, oh, it's a washer. And so washers are the ones I like the least amount. And so I have to find my capital R. And my capital R is that distance. And I know that was supposed to be straight. And you're like, you didn't draw that straight. But yes, when you draw a distance, it's straight. It's perpendicular to the axis of rotation. That's what R is. And so there it is right there. Now, what I do know is that the distance from the x-axis and up to your curve is that distance. That distance is called y, and y equals that far curve, which is 4x minus x squared. And this distance right here is 1. So this distance, which is equal to r, is equal to y equals 4x minus x squared. And then the whole thing, that's what the r is the whole thing, right? So I shouldn't have said this is equal to r. I should have said that this piece that goes from the x-axis to the curve is equal to y equals 4x minus x squared, which I'm going to call it just 4x minus x squared. And then this whole thing, the whole distance is r. So the r goes from here all the way to there. That's where r goes from, right? Okay, and so that means that r equals 4x minus x squared plus 1. And then my little r is going to go right here would be my little r. And because every single disc has a big R and a little r, but if I draw it right on top of this, then you won't be able to see it. So I like to draw a different one, but there's hundreds of them. There's millions of them. There's trillions of them. There's more than the national debt of them. And so there's where little r is. Excuse me. It goes from the axis of rotation all the way to the inner curve, which in this case, that inner curve is at y equals 3. And so this distance right here was 1. And then this distance right here from the x-axis to that that line, that's horizontal line, is 3. So the r is just equal to 1 plus 3, which is 4. Right? Is that okay? The inside r. So all of the inside r's, because for every big R, the inside R is only going to that horizontal line. Okay, so for our washer, we have pi, and then we have the integral of r squared minus r squared dx, right? And so our bounds are, we'll get our bounds here in a second. So our volume equals pi, and then the integral, and this is 4x minus x squared plus 1 squared. And yes, I would have to, if I was going to integrate this, minus 4 squared, that's 16 dx. And so if I was going to integrate this, I'd have to write that twice, and I would have to multiply that together, which would be 9 multiplies. And so I'm glad that it's only set up, because that would be annoying for certain, and it would just be a lot of algebra for not. Okay, so where are my bounds going from? This is in terms of x, and it's going right here, right? Because this is where I'm going to be drawing all these things that I have, right? So it's going from 1 to 3. So it's actually the same bounds as we had from the last one, right? From 1 to 3, right here, because this is my shaded area, and I'm drawing all of these just from 1 to 3. I'm not coming over here and having any of them. They're all going just right there, 1 to 3. So the same bounds as the other one. And actually, if we do another one with this same thing, the bounds will probably be 1 to 3 as well. And so let's go see, because I can see that we have it. And so all that's happened here is that they've got the same thing going here. And then they said the axis of rotation is the line y equals 3. So that right there is the axis of rotation. And so I always write to myself that's parallel to x, which would mean the disc washer would be dx, and it would mean the shell would be dy, which would mean my equations need to be solved for y, and they are. This would mean my equations need to be solved for x, and that's not possible. So I'm not going to be able to use the shell method. And now I want to know if it's a disc or a washer. So I get on the axis of rotation and I go towards my curve, and I notice that I was never in error. I was always in the shaded region. So that means it's a disc. And I'm like grateful it's a disc. For whatever reason, I think discs are nicer, is what I think, but you can think whatever you think. So this is my R right here. And so I'm having to now put some things together here, because what y is which was 4x minus x squared, that's from the x-axis all the way to the top right here. So this distance right here, from here all the way here, all the way to there, is what y is equal to. Is this going to work to find r? So this whole thing is 4x minus x squared. And I know this part right here, so the whole thing, I know what the whole thing is, but this part is r. And this part right here is y equals 3. This whole thing here, this is 3. This one's really tricky. It's almost has me. Okay, so from the x-axis to here is 3, y equals 3, and so this distance is 3. This distance is my r. This one's really tricky. And the whole thing from here all the way up to that curve, because remember, I'm going also here, right? All these different places with my r. This is my r right here, just that little distance right there. But that whole thing is 4x minus x squared. So what I know is that r plus 3 equals 4x minus x squared. And I'm wanting to solve for r. And so, but I know that the whole thing from the x-axis up to that curve is 4x minus x squared. I know that little piece is r, and I know that little piece is 3. So r equals 4x minus x squared minus 3. That one was really tricky. And so, and then my volume for my disk is pi, the integral, r squared dx. So pi times, and then this is 4x minus x squared minus 3 squared dx. That one was really tricky. And I'm going to go from the same bounds. I'm going to be going from here, x is 1, to here, x is 3, right? This is right here is that corner, which is right here at 1, and this corner right here, which is at 3. And so 1 to 3. Same bounds. I hope I don't have to do that one again because it'll probably get even trickier. And so let's go see what there is next. So that one was a disk. So I think actually we've done one of every type on that. Oh my gosh. There's another one. Okay. So we have the same story, right? Because we're just practicing getting it going, and we're going around some other, if we were going around the x-axis or the y-axis, we'd be like celebrating. It's easy when we're going around those. You get where that is. So this is y equals 5, x equals 5 that you're going around, and that is parallel to y. So that means the disk washer would be dy, and that means the shell would be dx. And that means my equations need to be solved for y. So it's not the dishwasher, which I'm grateful of because I actually don't like the dishwasher that well. I like the shell better. And so I need to go find all the pieces. When you do the dishwasher, remember you need to know h first. So we're getting where we're like, okay, well then this means my volume equals 2 pi r h dx, right? And so I need to go find r and h, and so right here is h, and h is always easy. It's parallel to the axis of rotation, and it's top curve minus bottom curve. So the top curve is, and you don't have to worry about where things are when you're doing top curve minus bottom curve. They sort themselves out, which is really nice. This is the same h that we had on a previous problem that we did, because every time we do a shell with this picture, that's what h is going to be. So what's going to be changing is what r is, and that's what we've got to find next. And so this was our h, and r, I always draw it because I'm a person of habit from the top of it, and there's where my r is. And so remember what I know. I know the distance from the y-axis. So I know the distance. This is the y-axis right here. This is the y-axis right here. And I know this distance right here from the y-axis. Do you remember what that's called? This is, I know I didn't get it quite level because it's 11:30. This is called y. It's called x, right? The distance from the y-axis to any point, you have to go to the side. So that's called x, is what that is. And now I have that same story. I think I've had that before. X plus r equals 5, right? So x plus r equals 5. So that means that r equals 5 minus x. So that when I put this together, I get my volume equals 2 pi, and then my radius was 5 minus x, and my height is 4x minus x squared minus 3, and this is dx, and which I almost ran out of room for, and the bounds are still 1 to 3 because I haven't changed what's going on this situation, so we don't have to think about that. And there we set that one up. And so what we're really practicing is, which one is it? and so that's why I have too many examples. Okay, example 8 of too many examples. And hallelujah, it's the last one. There is mercy. There is mercy. Okay, so here we are going around y equals 5, which is right here. We have the same story. This is parallel to x, which means the disk washer, I'm going to have to write it up here, will be dx, and the shell will be dy. And that means our equations need to be solved for y. And so I'm going to have to unfortunately use the dishwasher. I don't know which one yet, but I will find out. It's probably the washer because it's the last one, and that's my least favorite. That's what I'm thinking. Being negative, the way I can be. Okay, so we know that that you start on your axis of rotation, and I'm going to draw right when I go on the axis of rotation, I notice I'm in the air because this is going to be rotating around, right? And so that distance right there is my r. And that's a constant for every one that I would draw because it's going to a horizontal line. And that is going from, this is y equals 3 to y equals 5. So that's always 2 for r. And now I want to find out what lowercase r is. So that's what's going to be tricky on this one. So yeah, it's a washer. And I knew that because I knew, just because I'm being a pessimist here. So this distance right here would be the r, is what it would be. So the whole distance was big R, the inner distance is little r, and you have each one of those from 1 to 3 is what you kind of have going on. Okay, and so again, I'm going to have to be tricky here. I know that this distance from this point right here all the way to the x-axis, that whole way is y equals 4x minus x squared is what that is, right? And I know that this distance from right here to right here is r. So it's only that little air distance. And I know the whole thing is 5. So what I have, and remember I want to use 4x minus x squared. So I know that r plus 4x minus x squared, so this distance right here, plus this distance right here, is equal to 5. And I want to solve for r. So I have to take away 4x and add x squared both sides. So r equals 5, and I'm going to take away 4x, and I'm going to add x squared both sides. So this is my r, and this is my little r. And they're weird, aren't they? I mean, as far as, but once you get the hang of that, you always have to go to the x or the y axis. And because that's where things are defined from. And so once you get the swing of it, it's like, bring it on, put it wherever. And, I took this and I moved it everywhere, every which side, just so that we could practice that. And the hardest side for me was, I think it wasn't the last one, but it was the one that's almost stumped me was that one. Man, that one. I was really having to think about that. And so, but anyway, okay, so I digress. So, my formula for my volume is, because it's a washer, is pi, the integral r squared minus little r squared dx. From 1 to 3, we already know that, same bounds. So this is our volume, which is pi from 1 to 3, and then it's r squared, which is 2, and I broke my pencil lead. And so 2 squared minus, and then little r is not a nice guy. Little r is 5 minus 4x plus x squared dx. And then that would be set up. And so you don't have to multiply that and all of that, because that's the idea of just having to set it up, is to save you time and be done. And anyway, okay. That's great. That's done. Oh man, that was a lot of examples. Good golly. Thank goodness that most of them were just set up. Okay, let's be done. Let's be happy. Everyone smile.